I don't know if there are other people that that have the same problem. Maybe I can the next days register with Panopto, and I can also give you the link if you wanted to.
Thank you, Professor. I really appreciate that.
Okay, there are other two questions probably for Giorgia De Giacomi.
Hi, nice to meet you. I'm sorry, I have the exact same problem. I took the morning off today, but I work too, so, and I know many students this semester work.
No problem, okay.
Thank you so much.
Giorgia De Giacomi and Lorenzo Pisano now. If other people have the same problem, they could also ask me the same or say me the same necessity, then I will try to give them the link to the registration. Okay. 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 I hope that all the people that are interested to the course now are connected. Particularly a student, Sabrina Fiore, told me that she wasn't able to connect with this link, but as I said, it was a problem of visibility of the link. Now I wrote her that it is possible to connect, and I hope that now she will be able. Okay, Sabrina Fiore, now I can see you in the list. Okay. So, let's start with the lecture. I share my screen. Okay, this is the first slide of the course. Okay, my name is Fabrizio Passarini. I am an industrial chemist and I work at the Department of Industrial Chemistry of the University of Bologna. Particularly, my disciplinary sector is environmental chemistry. I work on the pollution, I deal with the pollution coming from different anthropic activities, and particularly with waste management, waste recycling, different types of waste treatments, let's say, and also the assessment of the environmental impacts coming from these different activities. So this is why I was called to teach this course. Concerning the environmental sustainability assessment in waste prevention and treatments. And also in the title, it is stated that the prevention is something different from the waste treatment, as we will discuss in the following days, following weeks. We will use a particular approach that is named the life cycle assessment to consider the possible environmental consequences, impacts coming from the different waste treatment activities. And so I think that you will be familiar with this tool at the end of the course. But first of all, my question is if you have some knowledge about this tool, the life cycle assessment, and what is your background, because I know that this master degree collects people, students coming from different bachelor degrees, so probably there are different background, different expertise for all of you. So I'm quite interested in knowing what is your past experience in terms of education, and to understand if you have some knowledge of the life cycle approach. Could you tell me something, for example, starting from you?
I have an economic background, and I heard about life cycle assessment, but I'm not very conscious about everything. Every aspect.
What is the course, the bachelor course?
Management and marketing.
Management. Okay.
I'm Rashid Bishar from Afghanistan. I graduated from mathematics and physics and was engaged in educational services for about 2 years in Afghanistan. Okay. And also I had a food manufacturing company. Where do you come from? Afghanistan. Afghanistan. Okay.
I studied economics at the University of Padua. And I chose this course either also to analyze and to do the life cycle assessment because I would like to know more about this. So that's it.
Okay, excuse me, your name?
Vale.
Italian. Okay, thank you.
My name is Marcus Geiger. I am in my bachelor's in Vienna in economics as well. And I have no real background apart from some documentaries, but I'm really interested in the topic, so that's why I chose this course.
Thank you very much. And from your house, just a brief survey. For example, Lorenzo Pisano. What is your bachelor and your background?
Well, I graduated in international economic relations about 2 years and a half ago. No, I've never studied life cycle assessment, so actually it's my first time that I studied.
Thank you. Laura Gabrielli.
I have a background in economics.
Okay.
And I also never learned about life cycle assessment. I know it, but never learned it in detail.
Okay. Alessia Pellonara.
Yes, basically same as Laura. So I know like what it is, the concept, but never studied properly.
Okay. You come from an economic bachelor, let's say.
Yes, me too. Tourism economics.
Evelina Osmanova.
I come from sociology background, but I did Erasmus in Denmark, and it was environmental risk. So I do have understanding of life cycle analysis.
Very well. Thank you. Sofia Mazzon.
Hello, I have an economic background. I studied in Padua during my bachelor, and during my Erasmus, I had a brief introduction about life cycle assessment, but I still don't know how to apply it, let's say.
Okay. Thank you, Sofia. MD Ataul Ghani Osmani.
Okay, hello.
Hello.
I have economics background in my bachelor. I never done any work in life cycle assessment. Okay. Thank you.
And Chiara Pini.
Hi, good morning. Yes, I have a economics background as well. So yeah, I saw something about sustainability assessment, but not really in a deep form.
Okay, thank you. Giorgia Di Giacomi.
Hi, so I graduated in political science with a thesis on waste prevention policies. So I can try to listen to this course. And we haven't seen a life cycle assessment at an academic level or deep level yet. So.
Okay. Martina Lombardo.
Yes, good morning. I have a degree in international relationships. I heard about the life cycle assessment, but I never studied specifically.
Okay, thank you. Edoardo Torella.
Yes, hi. I studied economics in my bachelor, and I've never seen life cycle.
Thank you. Giordano Spiga.
Hi, I also have a background in economics. I have done a bachelor in economics and finance in Bologna. Now I'm currently at ELMEC, so another economics master.
Yes.
And I just had one course in environmental economics, but was much more on microeconomic application, so cap and trade and that kind of policy. So never seen that kind of model.
Okay, thank you. Giorgio, Ben.
Yes, Ben, and yes, I have a background in economics too. And yes, I did an exam in my Erasmus program about life cycle assessment, and yes, I was interested to attend this course.
Thank you very much. Gizem Kukubayrak.
It's me, Gizem Küçükbayrak, you said, right?
Sorry.
No, it's okay. I studied economics as well. I didn't study sustainability in school, but I have some work experience, but not with life cycle assessment.
Okay, Ilaria Otero.
Hi, good morning. I graduated in business and management, but I've only heard about life cycle assessment. I don't have much knowledge on it.
Thank you, Ilaria. Lisa Monari.
Morning. I graduated in economics background for degrees, but I have not so much knowledge in this subject, but I would like to.
Okay. Martina Lombardo. I don't remember.
You already called me, Professor.
Okay, I didn't remember. Okay,
No
thank
problem,
you.
no problem.
Sayad Zaher. Sayad, probably before I see a hand on, but now he's not connected, probably. Simone Menghi.
Yes, I studied management and I just heard about life cycle assessment, but not in practice.
Okay, thank you. So just a brief survey to understand your provenience, your background, and to have an idea about your degree of knowledge of life cycle assessment. But I think that, yes, in general, it is not strange that you come, most of all, from economic and management courses. But I think that this approach is nowadays much diffused also among the economic disciplines. So I think that this could improve your knowledge about widespread methodology that is now very used also in some assessments that are not strictly technical, let's say. So just to say something about the course, we try to respond to answer to some of the main aims, objectives of the United Nations. Particularly, I underline these 4 Sustainable Development Goals, 11th, 12th, 13th, and 15th, even though probably other types of goals are matched at least partly in this course. But I think that these are the main topics that we will consider in our lessons. It is a course of 6 credits, that is equal to 30 hours, and it starts today and it ends at the 20th of May. There are already some dates considered for the next sessions of exams. And if you need some information about me, this is the email address which you can write, and some telephone numbers if you want to call me and to have a talk with me. There is also the LinkedIn page with my details. Okay, we can start writing the assessment method, because it's one of the main of the first questions that students are interested in. And okay, probably you have seen on the web page of the course, the assessment is made with an oral discussion on starting from a brief PowerPoint presentation. I say PowerPoint to understand what is, but you can use also other slideshow applications, Crazy, I do that, or what you want, Canva, okay. That could last about 10 minutes. That considers a case study of waste management or treatment and or of environmental assessment reported in literature, okay? You may consider one paper that you wanted to focus on and study in depth, or different papers that are concentrated on the same problem, so you can perform a discussion about the conclusions that are reported on the literature. In some cases, there could be also conflict conclusions, and you have to try to interpret what you have read. The topic is free. I have read many different kinds of reports. They are almost all very interesting because they are concerned with the topic of waste management, waste prevention, the LCA applied to different kinds of technologies, for example, for recycling or for recovery. And they could be chosen according to your personal interest. And yes, the importance is that you have not to repeat the content of the course that probably you have followed in these weeks, but after a general introduction of the topic, you may consider the case study, for example, or the approach. For example, if you wanted to focus on a methodological review, for instance, but in particular, you have to critically comment this topic, this case study, this methodological approach, giving your personal remarks on the assumptions, interpretation made by the authors. Okay, so what I think is more important is that you have to interpret the study that you have found and try to say something new, something personal on the study that we are going to consider. You may add a declaration of authorship similar to this that could attest that you are making this work on your own, and it will be sent by email at least 1 week before the exam. Okay, in PowerPoint or PDF, something that could be easily read by me, by my personal computer. Oral discussion could also range for some other parts of the course. For example, if I have some question about something that is near your presentation, near in the sense of the content of your presentation, I could ask something that has been said in the course. Okay, so please try to consider also the other parts that are not strictly concerned with your report. Okay. Okay, this is usually are an important part. If you wanted to ask me something about the assessment method, it is important that you make the questions just now. Please stop me and ask me something if you have something that is not completely clear. Okay? Yes, please.
This presentation will be prepared by each individual or like a group of? Sorry? The presentation will be prepared by each individual students or as a group?
No, it would be individual. Group. Only one presents, each one presents one study. Okay. Yes, it would be an individual study that you perform according to your own interest. Okay. But okay, the presentation will be quite brief. 10 minutes. It's a sort of
Professor?
reference. Yes, please.
We couldn't hear the answer. At least I couldn't hear.
The answer was, would it be an individual study or a group study, a group work? And the question was this one. I answered that it would be an individual study. Okay, so each one of you would present a different study.
Thank
okay.
You.
You're welcome. Okay. So, if you have not other questions, I can go on. Yes, please.
Is there no exam or is that the exam?
Sorry?
Is there no exam, like written exam, or is that the exam? The only assessment method is the presentation.
The assessment method is to assess what you are able to, how you are able to express your opinion about this case study that you want to do.
Okay, but there is no exam, like most usual exam.
No. I have not, yes, written questions or something like this. Probably I asked you something about the other parts of the course that could be connected with your presentation.
So on the 14th of June, we're all having a presentation and
okay. Yes, more or less it will last, I don't know, 20 to 30 minutes, because there is 10 minutes of presentation, and afterwards I will ask my questions, okay? There will be a discussion about this. Okay, so the learning outcomes. Yes, the aim of this course is to try to understand what is the waste management system, but also a waste prevention system, considering the European regulatory framework, because I think that it is one of the most advanced regulatory framework in the world, and it could be considered reference for in general, okay. And it is also a systematic view of the topic of waste management. And also the technical opportunities of prevention, recovery, recycling. We will try to see different types of waste, because you know waste is composed by different categories of materials. So we will try to understand what could be the most proper option to treat or to manage certain kind of waste. The criteria to quantify the environmental impacts, considering material and energy flows associated to waste management from a life cycle perspective. So again, the life cycle perspective, I mean, in particular, the life cycle assessment will be the main tool that we will see to understand which are the environmental impacts associated to waste management. So there will be an introduction to the regulatory framework, particularly at the European level, a description of what is an integrated waste management system, and also the composition of waste. Which kind of characteristics, of features we can derive from an analysis of waste waste composition or also physical-chemical characteristics of waste. Efficiency of separate collection systems, application of incineration and other thermal treatments, disposal in a sanitary landfill, and also recovery and recycling of different kinds of waste, so paper, glass, plastics, and some other case studies. Particularly the organic fraction deserves a dedicated treatment consideration. We will talk about the composting process and anaerobic digestion in particular, and also the associated environmental impact that could derive from different technologies applied to this kind of recovery. We will see also some case studies of different waste treatment systems, particularly derived from the experience of our group, of my research group, that have already performed different life cycle assessment studies on many kinds of different materials and wastes. So, in general, we will have some theoretical lectures and some exercises or presentation of case studies that we will comment together in order to understand if it is possible to comprehend the most sustainable practice among many options. In general, I will put my slides on this repository, the repository of the University of Bologna, virtuale. If you want, there are other two kinds of sources that are both required regarding the waste management practices. They are both, I think, available online, and they can be downloaded free of charge from the website of CRC Press. This is the homepage, but I think that you can find the title of these books among the different titles that are proposed by this publisher, and you may find these two sources free of charge. There is also quite a dated book that is kept in our library here that regards different case studies in Europe. We made a summer school some years ago, and we published all the lectures that came from that summer school. Okay, if it is all clear, I can go on. Okay, let's reset the topic of solid waste generation. Yes, probably you have already understood that I will talk about solid waste recovery, recycling, prevention, also not about liquid waste, for example, wastewater. I will not talk about wastewater. That is a completely different topic. So I will focus only on the solid waste generation, solid waste prevention, and solid waste treatment. Okay, let's start seeing a projection of the world of the Earth in 2 dimensions. But unfortunately, unfortunately, but you know that the Earth is 3-dimensional, and so it is difficult to report on 2 dimensions what is typically a sort of sphere. Okay, so there is, you may see this kind of projection. It is named the Mercator projection, but it is not the only one. You may see another kind of projection, that is this one, Here the difference is related to the fact that here the different areas of the countries are recorded according to their extension. So if you wanted to have a clearer idea of the extension of the different countries, you may consider this kind of method because it proportions the extension of the countries according to their real surface extension. Okay, so starting from this, we may consider that this is only a representation, of the physical size of the different countries. But we can try to reproportion the extension of the different countries according to the solid waste generation per capita. And we can see this kind of map. So, for example, here we are in Italy, and in Italy you may see that there is a big difference from its physical appearance, and this new size that is determined by the amount of waste generated per capita. But all Europe and the United States are much bigger than in the previous representation. While, for example, you may see African countries are much smaller, much thinner than before, and also other parts of the world, for example, in Asia and also in South America, the dimension is quite limited. This is a reproportion of the different parts of the world according to the waste generation per capita. But we can go on and see the proportion of waste recycling. And this is what happens when we try to have a new picture of the world according to the waste recycling. The waste recycling is like this. In Europe, in Japan, in the United States, we have an industrial framework that is able to recycle the waste that is generated every day. While in other countries, for example, in South America and in Africa and some other Asian countries, the problem is that the waste is generated in a certain amount, as we have seen before, probably surely a lower amount than in more industrialized countries. But the problem is that in these countries there is no industrial structure that is able to recover, recycle, and treat the waste that is generated. It is a very big problem for those countries. I said before that we organized a summer school, some schools in the past years, and we hosted also some African people that said, yes, we have a certain amount of waste generated also in our countries, but we are not able to recover them. In most cases, there are open dumps. That is something different from sanitary landfills. That means that the waste in many cases is not collected at all, or is burnt open air, in open air. So, in general, the problem is that you may have a certain amount of waste that is commonly generated, but with a very low amount of waste treated. And in general, the amount of recycling is less than 10%. One could say, but these data are quite old. Nowadays, the situation would be much different. Afterwards we will see some new data, but we will see that it is not so different from that picture. The problem of waste management and treatment is a problem of all time, we can say. But in proper terms. I have noticed, for example, this study that was published on a journal that is entitled Current World Archaeology, that reported that the recycling the Paleolithic. So our ancient relatives used to recycle some of their tools, or their instruments, after a first use. Okay. In many cases, the archaeologists are able to find, for example, some stones that have these double patina on both sides, that is the proof that they use to use again, to form, to also work again the same stones, to have different uses during the years. So after a first use, they could have other uses when the artisans work again the same stones. I have read also other papers on this topic, particularly a paper that was published last year, in 2021, with some Maya, some archaeologists that work on discoveries in Maya ancient territories, and they have seen that many materials that were used for civil application, let's say for temples, for houses, were used many times, and so they were recycled many times, because probably they need to use several times of the same materials. So in general, the problem of recycling is not something that is strictly connected with our era, but it's something that is common in human societies and since the ancient times, more ancient times. And it's a problem also of every part of the world. Okay, this is a study that was published on Nature. Nature is one of the most important scientific journals in the world. You know that Nature and Science are the most widely known scientific journals. And in this paper, Environment Waste Reduction Must Keep This Century, the projection of waste generation are estimated according to the growing population, but also to the growing per capita generation of waste. For example, in this other report, this other report is the report of the World Bank in 2018. It is named Water Waste 2.0. Probably there was a previous report with the same title. But in this case, you may see that the waste generation is increasing, or at least it's estimated to increase in all the different categories of countries in the world. Not only in the high-income countries, in which the waste generation is usually quite a big issue, but also in low-income countries, in lower-middle income, in upper-middle income countries. So in each kind of countries, the increase of waste generation is estimated quite regular in the following years. And this means that we will deal with a growing amount of materials that must be treated and recovered and recycled if we want to have some possibilities of living well in our planet, because otherwise we will fill in different parts of the world with landfills. Otherwise, because we must get rid of this kind of waste. Okay, we are in Italy, and in Italy we have a long experience of waste, we could say management, and improper disposal of waste. For example, these are marble plaques that are placed in different streets in Rome, our capital city, in Rome. There are 67 plaques that are sited in different streets of Rome, dating from 1646 and 1790. So they are very old. For example, in this case, this is one of the oldest plaques, dating back to 1646, in which it is said that the lords of the streets command that no garbage is put along the fence of this church on pain of personal imprisonment, 25 golden scudos, that are coins that must be paid, 3 rope tricks and other punishments if one was found to dispose of his or her waste along this street. Okay, so the problem of improperly putting the waste in some parts of the street is very old, at least in Italy, as it is proved by these marble plaques. But we have more recent affairs that have been reported also by the press. For example, in this case, we have sorts of pyramids of waste that were generated by putting all the mixed waste coming from different cities near Naples. Okay, because there wasn't, for example, an incineration plant, there wasn't enough space in the landfills, so this was a temporary disposal site for mixed waste before a possible subsequent treatment that could recover at least some parts of energy from this waste. This is a very old house to understand the dimension of these pyramids, okay, that were diffused over a very wide area. Some parts of this waste is nowadays either exported to Germany, for example, in which it is burnt, or burnt in a more local incineration plant that was built quite recently. But it is quite impressive, I think, to see all these amounts of waste that are not treated because there is no possibility of treating it in a territory. In some other cases, as you may see from these articles, that are not reported in Italy, even though they consider Italian territories. For example, this is again, a paper published on Nature, one of the most qualified scientific journals, talking about toxic legacy, because there is a lot of waste that is simply deposited on some areas. Usually it is sort of hazardous waste that is not properly managed, and usually it is burned in open air, and so you may see, for example, this picture, the land of fire, the land of fires, the triangle of death, because in this place there is quite impressive percentage of pathologies coming from the improper waste treatment, like this, like a burning in open air. Okay, it is called Terra dei Fuochi, land of fires. And for example, this paper, again, it is reported what is the map of illegal dumping sites of toxic waste in Campania. Again, published on a widely diffused journal in the world, in English, so it is completely available by all the world. These are the maps. This is the map of the different sites in which it has been recognized, it has been demonstrated that some toxic waste has been deposited in or under the surface, and in order to get rid of some waste that is not generated in place in the same territory, but in many cases it derives from northern regions. Okay, I think that we can stop for some minutes, okay, and a brief break. We will see in 10-15 minutes, okay? Okay. We are here again. There is another guest in this beautiful room. I hope she's able to connect with us. Okay. Okay. Let's go on with this presentation. Okay. Another interesting case is that this one. It is interesting because it's on the Tuscany hills that are known around the world for their beauty. But unfortunately, in this case, in Racolan, in the province of Siena, there was an illegal dumping of different tires, car tires, about 300,000. That were simply deposited in this hill. Fortunately, nowadays, in recent times, they have been removed, at least partly, by an Italian association of tire recycling. However, this was the photograph, the picture of this improper disposal of tires. But Italy is not the only place in which some not appreciable episodes happen concerning the waste management. For example, this is what happened in England, in which the different phone booths were a typical picture of the British streets. But nowadays, obviously, we have all our cell phones, and so they have been discarded and they are deposited in some parts, in some areas in which they are simply put without any treatment and any recovery. This is even more, let's say, concerning. It is named the aircraft graveyard. It started originally to store the excess Department of Defense's Coast Guard aircraft, but in recent years it was transferred in the sole repository of out-of-service aircraft from all branches of the US government. So we have a very wide extension of aircrafts that are made in many different materials, so they are not easy to recycle since complex mixture of materials. And nowadays they are simply put in a wide area in the United States. And when the problem is not visible, however, it could be present as well. For example, in this case, we have a lot of examples of sunk ships that were sunk at the bottom of the sea with their charge of, in many cases, hazardous wastes. Okay, so these are different points in which certain episodes of sunk ships happened in the past. So we know that in the Mediterranean, for example, there is a lot of waste that is simply deposited at the bottom of the sea. There is, the sea could be a sort of landfill, for example, in this case, but not only for the sunk waste, but also for the floating waste, because, you know, there are some vortexes that are present in the world that are able to collect a very high amount of plastic pieces They put them all together by forming a new sort of island that is estimated to be almost twice the size of Texas in the Pacific Ocean. It is known as the Great Pacific Garbage Patch. So a lot of plastic that is that has been put in the sea, or directly, either directly or through the different rivers in which people put the waste, the plastic waste, and the waste the rivers brought them into the sea. So nowadays there is a lot of plastic floating in the sea, and some of the plastic is under the sea. On the sea floor, for example, in this case, it is known as marine litter, or the amount of plastics or other kinds of litter that are deposited in the sea. For example, some parts of the plastics are already colonized by living beings that use these plastics as a sort of place in which they are able to live. But there are also some other parts of hard plastics that are deposited some kilometers under the surface, the sea surface. And I don't know if you are able to recognize this this place. It's a quite famous picture. You know what is this place? This place is a place, a site of, yes, a place sited on one of the most beautiful islands in the world, the Maldives. It is known as Thilafushi Island. Is one of the islands of the Maldives, and it is placed in this site. Okay, if you Google it, and if you enlarge the focus on Thilafushi, you may find a picture like this. Okay, this is Thilafushi Island, and this is the deposit of waste from which you may see the smoke coming from the surface. It is a smoke probably generated by the self-combustion of the waste that is deposited in the landfill created in this place. It is estimated that each tourist generates about 3.5 kilograms of waste per day. That is almost the double of each resident person. So every day in Thilafushi Island, they collect 400 tons of waste. Okay, that must be placed in some site. So also some beautiful islands are strictly affected by this problem. This is a tattoo of Pepsi that was found on a lobster that was fished in recent years. I don't remember exactly in which part of the ocean, but okay, it was found and it was published because it is very strange that the mark, the Pepsi mark, has been attached to the surface of this animal. But it enters also something like this. Okay, so we can say that in general there are many ugly experiences of improper waste management all around the world. Also in the oceans, because the plastic in the ocean is becoming a very urgent problem to deal with. So the solution would be to consider all the technologies that are available to treat the waste properly, to recycle it as much as possible, to recover, if not possible to recycle, at least to recover energy, to dispose of them safely, and this means to have some places in which we must put some plants, some industrial plants that are able to transform the waste into resources. But there's a syndrome that is widely diffused in the world that is named NIMBY syndrome. Maybe you have already heard about this. The NIMBY syndrome means not in my backyard. So, okay, we all agree about the importance of treating properly the waste. So the importance of landfills, the importance of incinerators and some other plants that burn waste, also recycling plants, but not beside my house. Okay, so here you may see different protests against the landfill, against, for example, the incineration plant, recycling, not incineration, but also against the composting plant, okay, because it could generate bad odors. Okay, put the smell somewhere else. For example, it is written in that carton, in that paper. Stop with the road. Also, and finally, there is also a protest against recycling centers. So you may have protests against everything that regards, that concerns waste management. But this means that you aren't able to implement effective processes of waste management, because in many cases citizens are against each kind of treatment. Is it only a problem of citizens? Unfortunately not. It is a problem also of politicians. And nowadays, there is a new syndrome that is named NIMTO, not in my terms of office. So please do not disturb me when I'm during my terms of office. Sorry. So I will postpone the solution of the problem when someone else will administrate my territory. Okay. Because I don't want to be responsible of some new plans that could be conflicting with the population. I want to keep my consensus among the population high, so someone else will deal with this problem. But if you postpone the problem every time, the problem cannot be solved. In general, we can say that waste management, each kind of waste management facility, waste management process, has its own environmental impact. Okay. In this scheme, we can see different kinds of waste management facilities. For example, here we have mechanical biological treatment. We will talk about this. In this case, we have anaerobic digestion, pyrolysis or gasification, the recycling and reuse incineration plant, the landfill, the composting plant. So in this case, we have a transfer station that is central among different kinds of facilities, and from this transfer station we have different parts of the waste according to its nature, its characteristics. But okay, when we think about the landfill, for example, we have some air emissions. We would have some groundwater pollution. Obviously, we occupy usually a very wide amount of soil, so this soil could not be used, for example, for fertilization. When we talk about incineration, for example, we have a problem of air pollution, but we could have also some water pollution because we use water for the flue gas treatment. So at the end, we will have some polluted, contaminated water that must be sent to a wastewater treatment plant. And for each kind of waste management facility, we could have some environmental problem, environmental impact. So, if we want to understand what could be the solution, we must consider that we must put implement an integrated solid waste management, okay, from a life cycle point of view. This means that after a collection and sorting of the different waste, we must use every leverage that we have in our hands to allow the most, the highest recycling of materials and recovery, if it's not possible to recycle, and limit at most the environmental impacts coming from, for example, the final disposal. But we must consider that for each kind of not only of waste, also of energy, of other materials. Because if you wanted to manage, I don't know, a composting plant, you need energy. You need energy to move all the waste, to, for example, force. You need other types of materials, for example, fuel, okay, for all the machineries that you use. And at the end of these different types of treatment, you will have secondary materials that could be recycled. These are the products, or compost that could be used as sort of fertilizer, useful energy, but you will have also something that would have adverse effect on the environment, air emissions, water emissions, inert landfill materials, something that must be put at the end into the landfill. So we could have different kinds of environmental effects, even though we use perfectly the different options that we have. Again, in this table, the DEFRA is the Department of Environmental and Rural Affairs of the United Kingdom. All the possible environmental issues that are associated with different kinds of waste management activities are recorded in terms of noise, odor, dust, flora and fauna, soils, water quality, air quality, climate, and other kinds of adverse effects, environmental impacts, we should say. In general, apart from some strange considerations in which an indirect benefit could be related in some cases to the landfill. However, the landfill reports the worst performance almost in each kind of category, for noise, for odors, for dust, for flora, fauna, so for solids, water, and air quality. But most of all, for climate. You know why climate is so affected by the landfill? Why one of the biggest problems of landfill disposal of solid waste is related to the climate impact. Climate change, it means. Also, if some people from connected remotely want to answer to this question. What is the connection between landfill and the climate?
Maybe the fumes, because waste makes fumes which goes to the air freely.
Okay, there are fumes could come from the combustion of waste. It could happen that also a self-combustion takes place, but it is not, at least if the landfill is properly managed, this would not happen. But there are other emissions into the air from the landfill.
Biogas, maybe?
The biogas, yes, the biogas, that comes from a degradation of organic materials. Why the biogas is generated in landfill? Because you have different layers of waste that is piled into a hole, okay, in general. So you have different layers of waste, of rubbish. In the bottom layers, you may have anaerobic conditions because the deepest layers are not in contact with the atmosphere. Okay, so after a few times, an anaerobic condition takes place, is generated. And in anaerobic conditions, the organic materials is transformed into methane. Methane is CH4, this is the chemical formula for methane, and CO2. CO2 is the most widely known greenhouse gas, but it is not the most effective greenhouse gas. For example, methane is estimated to be 20 to 30 times more effective than CO2 in determining the greenhouse effect. Okay, so 1 kilogram of methane equals 20 to 30 kilograms of CO2 in terms of climate change. Okay, and since the anaerobic degradation of organic materials generates methane, biogas that is composed by methane and CO2, this means that you have a lot of emissions of climate changing substances, gases into the air. So this is why the landfill is one of the most problematic, of the most critical type of treatment when we talk about climate. Okay, but for each kind of activity, you may see that there is a possible environmental consequence, and in general is not a beneficial consequence. Only in some parts, for example, for composting, for anaerobic digestion, you may have some benefits from the waste management activity. However, we must quantify what is this critical emission of something that could be critical, could be impacting from an environmental point of view. For example, in this case, there was a quantification of dioxin emissions. Do you know what is dioxin? When we talk about dioxin, have you ever heard about the dioxin? Dioxin is something that is it has this kind of formula. This kind of formula. I don't know if you are able to see what I pictured on this table, but it's not important to see the formula. It is only to say that there are two aromatic rings that are connected by two oxygen atoms that form two bridges. And on these rings, you may have in some parts, here or here or here or here, chloride atoms. Okay, so you may have from 1 to 8 substitutions of chlorine on these rings. The dioxin are connected with the are particularly dangerous because they are known as carcinogenic substances, and they could be formed by the combustion of many kinds of materials. Not only waste, but waste is in general considered one of the most important starting materials from which dioxin could be formed. However, in this table you may see that waste incineration is responsible for, in 2000, 0.5 grams of toxic units in Germany, compared to the 400 grams of toxic unit that used to be in 1990s. The fact is that waste incinerators have been much improved in recent years, so their emission of dangerous substances have been limited of several orders of magnitude, as you may see, in recent years. But if you compare, for example, this amount of dioxin coming from waste incineration with other types of sources, you may see that, for example, we have 6 times higher emission of dioxin from power stations. And power stations are not so critical in the people consideration. Okay, not critical as well as the incineration plants. Metal extraction and processing, 40 grams, that means 80 times higher than the waste incineration. So in general, also domestic fire installations, it is estimated less than 10, but probably is much higher than the amount of dioxin coming from waste incineration. What is the problem? That in general, from domestic installations, the dioxin could be generated, but they aren't usually monitored. Okay? So we can only estimate the amount of dioxin coming from domestic fire installation. Okay, while the waste incineration is strictly controlled, strictly monitored every day. So when we see at some figures, some data, we can say that in general there is an overestimation of environmental impacts related to certain practices and maybe some underestimations associated to other kinds of sources. For example, traffic is less than 1, but again, it is not quantified. Okay, so at the end, the Federal Ministry for the Environment says if that energy were generated using traditional power stations, there would be 3 more tons of toxicant in the air. Okay, because by burning waste, we are able to recover energy. Okay. But if you wanted to find an overview, wide review of possible adverse impacts, adverse effects of different kinds of waste management practices, you may find this study of the World Health Organization of 2008, Population Health and Waste Management, Scientific Data and Policy Options. It was a workshop that was held in Rome in the 27 years, that reported the different kinds of health effect that was related to some kinds of waste disposal sites. Summary of epidemiological evidence. So we can see different health effects here reported. For example, teratogenic effect, but also I don't know, some carcinogenic effects. And the problem is that the levels of evidence is in many cases inadequate or limited. In all cases, these are the level of evidence that are associated to the health effects of this kind of disposal sites. So in general, we cannot have a final definitive response from these kind of studies. For example, here, respiratory hospital admissions per ton of waste. You may find here average values and the error bars related to these values, from which you see that, for example, mechanical biological treatment has a poor evidence of new admissions for respiratory diseases into the hospitals. There could be moderate, but is the minus 6 powers, that is the level of admissions per ton of waste incineration. So very few amounts of people are affected by these different practices. So again, the estimation of the environmental effect related to different waste management activities is very difficult, because in many cases you may have only long-term effects that are very difficult to estimate, and they could be, however, very little consequences. For example, in this case, again, respiratory hospital admissions per ton of waste due to the anaerobic digestion, pyrolysis, gasification, incineration, and so on. So, if we want to summarize the problems that are related to waste management and impacts, we can say that there could be different consciousness levels among the population that could have concern for some kinds of waste treatment, and in other cases it could neglect important environmental consequences related to other types of practices. So in general, population concerns could vary very much in the different territories. We need to avoid illegal disposal and to perform reliable and safe waste management, waste treatments. We need to do it. Otherwise, as we have seen before, we may assist to illegal disposal of waste with very high environmental consequences, like in the land of fires, in which hazardous waste is buried or it is burnt in open air, producing a lot of hazardous toxic chemicals in the air. So we must know, and people, citizens must know, that a proper waste treatment is unavoidable if we want to prevent some very important cases of environmental consequences. It is always preferable to have legal plans that deal with the waste if we want to avoid the environmental impacts that could come from illegal practices. Obviously, there is some difficulty in an exact risk quantification. So, for example, people want to understand if I build a new incineration plant near here, what would be the risk of the insurgence, for example, of a cancer for me, for my relatives? There is a concern about these possible adverse health effects of new plants. And the quantification of risk is usually very difficult, at least in precise terms. We use also to quantify the risk coming from the emission of different chemicals, chemical compounds from incineration plants. And we calculated that even considering the highest deposition in the nearby territory, the risk was under 1 million, 1 over 1 million people. So in general, here we have only some thousand people. So the risk could be quantified in a fraction of one person, okay? Some 0.001 people per person, sorry, in an area that is like Rimini, for example. So the quantification is of a risk is very difficult to perform. And furthermore, there is a problem of a multiplicity of impacts to be taken into account. So, for example, the environment, the human health. One problem is to generate, for example, cancer to people that live near a plant. Another problem is to add new emissions of greenhouse gases into the air, because greenhouse gases could affect the environment. The cancer affects directly the human health. Okay. There could be a problem at a global level. The problem of greenhouse gas is a problem of the entire Earth, not only of somebody that lives near a plant. Okay, there are other problems that are related to the local level. And finally, the necessity of knowing current or predicted impacts. What happens now due to the presence of a plant, for example, near here? What could happen if we substitute, if we replace the plant with a new plant or with a new technology, for example, that possibly will lower the emissions and so will limit the environmental impacts around the plant itself. Okay, but in general terms, when we think about the environmental effects related to waste, what do we think about? In your opinion, which are the environmental effects that we must take into account when we consider the waste management?
Water and air emissions.
Okay, so emission of pollutants, obviously. Okay, emission of pollutants into the water, into the air, into the soil also. So the contamination of different environmental matrices. This is a concern that is related to the environmental effects related to waste. Other ideas?
Resource scarcity.
Resource scarcity. Yes, it is true. It is important to consider that if we waste, if we get rid of materials that we consider waste, we will not have those materials in the future. They will not be available for us when we want to build new things, for example, to produce new compounds, new materials and products and so on. So the resource depletion, the consumption of resources on the earth is a very important and problematic environmental effect. And finally, I don't know if you can consider other types of environmental effect. The first that I had in mind is the exceeding waste generation compared to the capacity of managing it and disposing of it. So we have a lot of waste that is not collected at all because we have not areas in which we can place, in which we can treat our waste. So this is a very dangerous situation because in this way we could have also sanitary problems, health problems related to the presence of unsorted and uncollected waste in the streets. Then the air, water and soil pollution, as you said, and the rapid earth resource depletion. This is a representation of a paper that was published in the journal New Scientist some years ago, in which one researcher tried to estimate the years that we have from now on if we wanted to go on with the same rate of consumption of different compounds or elements. Okay, there are different bars with a different color that refer to elements, various elements. For example, I don't know, hafnium. But also tin, uranium, zinc, aluminium, antimony, chromium, copper, and so on. The darker extension of these bars refers to the rate, to the years that are left if we go on with the same rate of consumption of the United States. Okay. The larger color refers to the year that we have if we go on with the same rate of consumption of the present population in the world. So the rate of consumption of the United States is generally much higher than the rest of the world. And for some of these elements, only few years are left. For example, in particular Egypt, I don't remember where is Egypt over there. If we wanted to go on according to the reserves, the known reserves of the earth, because we are exploiting the mines too much in these years, and probably in the future we will be not able to have the same amount of elements for going on with our high technology sectors of the industry, which are the most the sectors that consume more these kinds of materials. But we will discuss about this also in some following slides. Okay, so the rapid Earth resource depletion is one of the biggest challenges I think that we have in the future, and it could be faced also with a proper waste management if we will be able of improving either from a technological point of view, but also from a managerial point of view, our normal practice, particularly in our industrialized time. Okay, we can stop again and start at 11:15. Okay. It's difficult to hear my direction. There's a persistent movement. Good. Start again. Okay. To say something about the use and consumption of different materials. This is one of the main and the most important action plans that was put in action by the European Union on the sustainable consumption and production and sustainable industrial policy action plan. It was approved in 2008, and this year is the same year in which the Directive on Waste was approved, 2008. This Directive on Waste was amended in more recent year, in 2018, but it is still in force, that directive that was amended only in some parts. However, this communication on the sustainable consumption was important because it considered different aims to promote sustainable production and consumption, considering the social and economic development within the limits of ecosystem burden capacity, and dissociate economic growth from environmental impacts. This is the meaning of decoupling that is represented in this graph that you probably may have seen different times. Hopefully we could have an economic activity that is growing, so the GDP is a curve that is increasing in time, while the resource use would decrease, and this is the meaning of absolute decoupling, or increase less than the GDP, and this is the meaning of relative decoupling. The relative decoupling obviously would be less than the absolute decoupling. That is the real aim of this communication, of the strategy of the European Union. Other aims are to improve the environmental and social performances of products and processes, greater awareness by enterprises and consumers, to reach the diffusion of the green public procurement. We know that the green public procurement is an important tool for the countries, for the member states, to generate incentives for the greener production, because they are able to purchase, to buy a lot of green products, and so the market could be influenced by the countries themselves towards a greener production of the different companies, different enterprises. To increase the European and the global market growth in environmental technology and ecological innovation sectors. So another aim was to try to be more competitive in the world in terms of technologies for the European Union. Okay, this is another representation of the decoupling concept. Another important document that was published by Europe, again near to the concept of waste and resources, is this roadmap to a resource-efficient Europe that was published in, I don't remember exactly, in 2018. No, 2011, sorry. Okay, this is the table of content of this document. which contains also this important chapter 3, transforming the economy. Sustainable consumption and production, so it recalls the previous document, turning waste into a resource, that is probably the aim of this course, considering waste as a resource, supporting research and innovation, and it is quite similar to what we try to do in the university, in the research centers. So this chapter is particularly central in the concept of European Union related to waste management and resource management. This is a very nice document because it envisages the possible development of the different industrial sectors in Europe in order to be more sustainable in the future. Unfortunately, not all the aims have been reached in the next years, but for example in this table, it's quite difficult to read it, I think. In this table, all the different sectors, for example, fossil fuel, materials and minerals, water, air, land, soils, biodiversity, marine resources, waste, can be affected by different kinds of sectors, for example, that are energy, food, buildings, mobility, and other initiatives. So, for example, if we think about buildings, the aim that we could try to reach for fossil fuel is to reduce fossil fuel use via better energy efficiency and renewable energy use in buildings, to build zero energy buildings and increase the renovation rate of existing buildings. And for each resource, different kind of actions could be taken in the various sectors. This is an interesting document of strategy in the future, and particularly the problem of waste is here reported because waste has something to do with all these sectors, with energy, with food, buildings, mobility, and other kinds of initiatives. So the waste is a strategic sector that must be taken into account if we want a sustainable future. The framework program 9, I don't know if you are aware about these framework programs that are programs of funding, of financing the research in Europe. It is called Horizon Europe, and and comes after the FP8 that is commonly known as Horizon 2020, the previous framework program of financing the research in Europe was named Horizon 2020. And also in this new framework program, what is said is that we want to tackle climate change. 35% of the budgetary target is related to tackling climate change. And we wanted to help to achieve the UN Sustainable Development Goals, also for Europe. So this means that a very wide extent of money is devoted to reaching this Sustainable Development Target, and particularly the climate challenge. Again, in 2014, this new communication towards a circular economy, a zero-waste problem for Europe. The circular economy is used also in an official document, not only in academic discussions, not only by environmentalists or environmental associations, but it becomes a real strategy for Europe, which takes into account the different steps in the life cycle of materials or products, because we want to implement a circularity that avoids as much as possible the amount of residual waste that is simply disposed of without any type of valorization, let's say. And this circular economic package means that it is a series of different directives that were approved together. This package was approved by the Commission, or better, by the European Parliament in April 2018, so just 4 years ago. And it put some targets for the recycling of waste, particularly for the recycling of municipal waste, 55% by 2025, 60% by 2030, 65% by 2035. Unfortunately, we are far from these targets, even though we have different situations among the various countries in Europe. But we will see some figures concerning the performances of the different countries in reaching these targets. For packaging materials, there are different targets. In general, 65% by 2025, but there are also some objectives for plastic packaging that must be recycled at least 50% by 2025 and 55% by 2030. Why? Because plastic is much more difficult to recycle than other types of materials, than, for example, metals, glass, paper, that are much more easy to recycle. Plastic is something that it is quite difficult from a technological point of view. Another target is the 10% maximum of landfill disposal by 2035. Okay, so we must reduce the amount of landfill, the amount of waste that goes into a landfill until less than 10%. From 2023, separate collection of bio-waste will be compulsory to promote composting. But also for textiles. You know some experiences of separate collection and recycling of textiles? Not of the use of textiles, because also here in Rimini probably we have some bins in which you can put used clothes, for example. But they are bins that want to contain only reusable clothes, not clothes at their end of life. Okay? Because recycling textiles is a challenge. It is still a challenge in European countries, and particularly in Italy. It is not performed, it was almost not performed in any part of European Union, but also in other parts of the world. And also hazardous material in household waste. It has paints, pesticides, waste oils, solvents. One could think that for household waste we could not have hazardous waste, but indeed there are some categories of waste that are generated by households that are still hazardous. And the European Council communicated that were definitely opposed the core proposal of directive on circular economy, which modifies 6 waste directives, also the 98 of 2008, that was the mother directive on waste. It was replaced by a new directive in 2018. And this was the first circular economy package that was approved by the European Union. But there is a new circular economy action plan that was approved in 2020, only 2 years ago. New circular economy action plan shows the way to a climate-neutral, competitive economy of empowered consumers. And this plan is part of the European Green Deal that was presented by the European Community in March 2020, and it aims to reach the climate neutrality by 2050. In 2050, Europe countries want to reach a neutrality from a climate point of view. That means that the amount of CO2 that is emitted into the atmosphere equals the amount of CO2 that is absorbed in many ways by the territories. Okay. If possible, the amount of CO2 absorbed would be higher than the CO2 that is emitted into the atmosphere. European Parliament approved it on 10th of February 2021, so 1 year ago, requesting more stringent targets and mandatory targets by 2030. So they said in the European Parliament, this is not sufficient. We must do even more than what is stated in this new circular economy action plan. It was approved but with some remarks that said that we would make also better than what is reported here. And in general, this is the aim of the European Green Deal, to transform the European Union's economy for a sustainable future and leaving no one behind. To do this, we have several tools that are reported in this slide. A zero pollution ambition for a toxic-free environment, but also building and renovating in an energy and resource-efficient way. The mobility, farm to fork, so several strategies considering the agricultural activity, the tertiary sector, the industrial sector, and so on. Okay. So one could ask, but which is the situation now? What is the circularity performance of our world nowadays? Because the circular economy is something that we wanted to put as an aim, as a target, but nowadays, how we are behaving in this particular topic. Every year, a circularity gap report is published by an association that makes some calculation and tries to understand which is the amount of materials that are cycled, recycled, if compared to the total material that is used in the world. So this was the circularity gap report published in 2018 that estimated a global circularity metric of 9.1. 9.1 is less than 10%. That was the figure that we have seen before. Less than 10% of the material inputs is something that comes from the recycling of other materials. Okay? Because 92.8 billion tons, a huge quantity of materials, is used every year to build new products, new buildings, new cities in the world. But only 8.4 billion tons of these materials comes from a recycling. This was the estimation of 2018, but unfortunately, some years after, a new estimation in 2020, 2021 said that it was not exact, this estimation. The right estimation was 8.6, not 9.1, so even less than the very low amount of circularity index that was calculated some years before. okay, since the launch of the Secretariat report, we have seen a significant body of new scientific publications, and they have also updated. This allows for the use of more accurate data in some cases that led to the calculation of a new circularity index that is less than 9.1%. It is 8.6. Which are the inputs of this very huge amount of materials? If you look at this report that you can find at this link, I will suggest many different links during the classes that are other literature suggestions further than the two books, the three books that I mentioned at the beginning. So if you give a look to this report, you may see this this map representation of resources that are put into the market. So you may see the minerals, ores, fossil fuels and biomass that enter into the market by different types of activities, for example, mineral mining, ore mining, extraction of fossil fuel, forestry and farming, as for the biomass. It could be used for several applications. The societal needs are represented in this final column: housing, communication, mobility, healthcare, services, consumables, and nutrition. Of the total 100.6 gigatons of materials that are input into the market, only 8.6 gigatons are cycled resources that here you may see can be recovered by what is waste. Okay, something is emitted, something is dispersed. There is a net addition to stock in use. I mean, we are growing in terms of stocks. We have a lot of materials that are stockpiled in some of our houses, for example, that are not used, but they are not disposed of. And finally, some waste that is only partially cycled and used again in the input. Here, another representation of the different kinds of activities that are connected with waste. This is an estimation that is performed by the Yale University that every year published this Environmental Performance Index. This is the edition of 2020 in which some data on the types of fates of solid waste are recorded. Let's see the different kinds of treatment, of management of solid waste in the world. Okay. 31.1, the greatest bar, the longer bar, is relating to the waste that is uncollected or missing, completely uncollected or missing from some calculation. So about 1/3 of the waste is lost, okay, without any type of treatment of management. Unspecified landfill. Second in this score is the landfill. Unspecified, it means that we are not able to say that if these landfills are properly managed or not, properly or not. 3, open down. Again, a simple disposal of waste in holes or in some areas without any previous treatment, without any valorization. Open dams means a landfill that is completely uncontrolled. This is the third one. Fourth, recycling or composting. Okay. In this case, the estimation is 14.7. That is not much more than 10%. Incineration 9%, sanitary energy 7%, control energy another kind of 3%, and other 1.1. So, summing the amount of waste that is disposed of in the different kinds of landfills, plus the amount that is not collected, that is simply put in open spaces, we have a factor of 1.1, okay, plus 18, that is more or less 50, open down 15, so 65, sanitary landfill is 7, so 72, 75% of the overall waste is put in some place without any recovery. Okay, this is a final conclusion that we can make from this data. That is quite concerning if we think about the problem of waste and its environmental consequences. The circularity of the European economy. This was published by the European Environment Agency. It was published in last year, in January 2021. And here we can see the different kinds of materials and the amount of recycling. For example, fossil fuel. In many cases, fossil fuel are used to generate energy. A very low amount of fossil fuel is transformed into plastic stuff. So the main use of fossil fuel is to burn, not to transform into materials, polymetallic materials, okay? So at the end, the amount of waste deriving from these fossil fuels is recycled at a percentage of 3%. Only 3% of these materials coming from fossil fuel is really recycled. All the other 97 is simply or either landfilled or burned, and so it becomes gas. As for the biomass, the real recycling of all the biomass, that means also wood, and means also the amount of waste that we can collect and transform into compost, is about 9%. So the recycling also in this case is very low in terms of recycling of biomass. Metals are more precious, and it is also more traditional, the process of metal recycling. So in this case, we can reach a higher amount of 25% of recycling that comes from the metal waste. And finally, non-metallic minerals amount to about 15% of recycling. Here in Europe, overall, we have a circularity index of about 12%. Nearly 12% of materials were recycled in the European Union, 27, in 2019. Also in Europe, in which we have the most advanced, we could say, recycling practices, we are able to recirculate only 12% of the total material that is wasted. And finally, just a brief sight at a very big problem, the problem of food waste. A third of the food produced for human consumption globally about 1.6 million tons per year is lost or wasted. This is an estimation that was made in Europe, but this is true also for USA, according to an agency of the USA that reported something similar, the US Department of Agriculture. More than 1/3 of vegetables and fruit is commonly discarded. It is discarded in different steps of the production. It could be discarded at source when during the agricultural activities, and because in many cases the vegetables and fruit do not respond to the strict requirements of the regulations. Probably they are bigger or smaller than what the market pretends, and so they are disposed of, they are discarded. The cost of food waste globally is estimated at around $2.6 trillion US dollars, of which $1 trillion is incurred from greenhouse gas emissions. Water scarcity, biodiversity loss, increased conflicts, and loss of livelihood due to issues such as soil erosion, nutrient loss, reduced yields, wind erosion, and pesticides exposure. So the problem of wasting so high amounts of food reflects in different environmental impacts that are here reported, not only environmental impacts, but also social impacts, including conflicts, for example, and also economic ones. Food waste accounts for 4.4 gigatons of CO2 equivalent per year, which represent 8% of global anthropogenic greenhouse gas emissions. In comparison, the overall emission from China, USA, and India are 12.4, 6.3, and 3 gigatons of CO2 equivalents per year. So the equivalence per year of, simply due to the amount of food waste, is much more than the emissions coming from India, a country like India, and is of the same order of magnitude of the amount of CO2 emitted by USA. Okay. Are there questions, curiosities, something that you wanted to discuss, to ask? Also for those who are connected remotely. Have you something to add, to comment, or to say about this? Okay. If not, I add only some words about the definition of waste, because here I'm talking about the waste management, the waste treatment, the waste prevention also, but we haven't yet defined precisely what waste is. And so here, a definition of waste. The definition was provided by the European Directive 98 of 2008, that says that waste means any substance or object which the holder discards or intends or is required to discard. Waste is a mix of different materials that could be divided in classes, each one having peculiar physical-chemical features. So let's focus a bit on the first part of this definition. Waste means any substance or object which the disposal discards. So if somebody discards a material product or something like this, this must be considered waste, even though the waste is still operating, it is still working, for example, or intends or is required to discard. This means that there are holders of materials or products that cannot keep their materials because they are required to discard those materials. For example, in some industries, in some enterprises, in some companies, if they generate as discards something coming from their main activities, okay, something that is not the main product that they want to produce, probably this could be a waste and it must be treated as a waste. So they cannot say, okay, I can keep this material as long as I want, because probably if in the future it could be useful. No. If they are not able to transform it in something that is useful presently, they could not keep it, okay, as long as they want. But they must discard it and send it to other companies that are able to either transform or dispose of it. So there is something that must be considered waste and must be discarded by the holders. And in general, we have different materials that compose the waste. And it is important to divide, also from a methodological point of view, all these complex materials into classes, because if you wanted to recycle waste, you must divide as possible into the different classes, because each type of classes could be recycled in different ways. Okay. It is different if you have polymeric substances from ceramic materials or glass materials. And if you wanted to perform a good, effective recycling, you must divide the complex amount of waste into different classes. And we will see something in terms of different classes representing the total amount of waste. But in general, when we talk about waste, the simplest subdivision, the simplest classification are like this. First of all, they are divided according to the source type. I mean, which kind of activity generates the waste. Usually, for waste, we use the term generation, not production, because production is something that you produce on purpose, while waste is something that you generate unavoidably, let's say. Okay. So according to the source type, we could have urban waste, so the municipal, you can say also, you can see that is named also municipal solid waste or household waste. That is the waste coming from sites that are used as dwellings, but also those that are similar to these urban waste. And those laying on public areas. For example, if there is some waste, some types of stuffs on the beach, okay, that are collected by people that take care of beach, and they must be considered urban waste. But also, for example, that waste that is generated by also economic activities. For example, here at the university, we could generate, for example, some papery waste. I don't know, something like this. Okay, or also the sheets that we use to print something. Okay, if we generate this paper waste at home, it is completely the same that if we generate this waste here at the university. So, since they are similar, they could be treated, collected and treated in similar at the same time. Other types of materials are those named as commercial waste or special waste. In fact, all the waste deriving from an economic activity. Okay? So special waste could be different, also hazardous materials that are generated by industries. In Italy, this distinction bears also a legal significance and also some economic consequences. But you may divide the waste also according to the hazardousness of materials. So you may have non-hazardous or hazardous waste. For example, the non-hazardous waste could include discards of plastic materials, ferrous scraps, outdated devices, also waste from electric and electronic equipment. But they are non-hazardous, while there could be hazardous waste that are not only generated by companies, by industries, but also by households. Because, for example, neon lamps or LED accumulators coming from our cars, for example, exhausted mineral oil or solvents that we could use in our houses are hazardous waste that are generated at households, but are households and not by commercial activities. So these are two main differentiation, classification of waste according to the source and according to the dangerous properties of the waste themselves. Okay. Okay, I think that we can finish here, because there are only 2 minutes remaining. If you have questions. Otherwise, I may upload the slides on Virtuale, so you will find them today, as soon as I can. And we will see tomorrow, okay, at 9. I don't remember exactly the place, because every time I think that there could be a change. Okay. If you wanted to come in presence, tomorrow we will be in Briolini 5. Briolini, do you know where is Briolini? It's not far from here. We are quite near. Okay. See you tomorrow.
Thank you. Bye.
Bye. See you.
Thank you.